Okay, so I'll be going through alcohols and carboxylic acid and ester. So in actual fact, we have gone through a little bit on alcohol and carboxylic acids already, because at the very front when we did the introduction to organic chemistry, that part, we highlighted what's the functional group for each of them. Okay, so just a quick one. Okay, for alcohols, functional group come. Matthew, help me. What's the functional group?
Like the -O-H.
Okay, so this is called the hydroxyl group, so that's correct. Okay, next one, Joaquin, help me. What's the functional group for carboxylic acid?
The COH thing.
COH. So to be more precise, it's a C double bond O to the carbon and the single bond OH to the same carbon as well. So this is called the carboxyl group. Okay, so we have covered a little bit of this already at the start. We are going to cover them a little bit more in details now. Okay, esters is actually formed from alcohols plus carboxylic acid. Plus carboxylic acid. Okay, so we are going to cover, that's why it's under the chapter of alcohols and carboxylic acid, because it's a formation from both of them. Okay, so let's start. So what exactly are alcohols? So alcohols are organic compounds with the hydroxyl functional groups. So alcohols itself is a homologous series. Okay, itself is a homologous series. Okay, so you can see here when we have this is propanol. This is the functional group over here. You just focus on the OH. Okay, so all alcohols actually will contain carbon, hydrogen, and because there's an OH over there, they will also contain oxygen atoms. So, Kiran, help me. Can I call alcohols hydrocarbons? Can I call alcohol hydrocarbons? Kiran can talk, right? Kiran, hello. Okay. No, he can't talk. Never mind, Matthew, your turn. Can I call them hydrocarbons?
No.
No. Okay.
Yeah, no. Because called oxygen.
Yeah. So hydrocarbons are organic compounds that contains carbon and hydrogen only. So in this case here, it contains oxygen as well. So I cannot call this hydrocarbon. Okay? I cannot call it hydrocarbons. I can only call, that's why this is not hydrocarbon. So this guy here is not hydrocarbon. Okay? Now, let's carry on. So the general formula now. So general formula for alcohols is CnH2n plus 1 OH. So to write again, CnH2n plus 1 OH. You realize the functional group is apart from the C and the H. So don't combine this in, please don't combine this in. So have the OH separate, then it's a CnH2n OH. Okay, so let's give it a try. Next one, Joaquin. Okay, the general formula is CnH2n plus 1 OH. Can you give me the can you give me the formula for butanol?
C4H A9 OH.
Yep, correct. So this is butanol. So make sure you know how to apply the general formula for the alcohols itself. Okay, so I think by now you realize general formula, you are more or less quite familiar with it already. So I don't think there's any issue here. These are just some additional work examples of the alcohol itself. Okay, so look at the way how it's written. C4H9OH, the functional group is separate. Okay. Okay, now, names and formula of the alcohol. So you can see here methanol. So 1 carbon alcohol. So this is when N equals to 1. Then you got this formula. The structural formula will be this. This is the full structural formula. Now, I don't really, you sometimes will see formula like this, CH4O. This is when they condense the whole thing together, like literally how many carbon, how many H, how many O. They don't draw the functional group separately. Okay, but this is still your molecular formula of your methanol. Okay, it just tells you how many carbon it contains, how many hydrogen it contains, how many oxygen it contains. It doesn't tell you the structure. So only the structural formula and the full structural formula will be able to tell you the structure. The molecular formula is just how many atoms are there inside there. Okay, so just take note of it. So we have ethanol, propanol, butanol. I'm not going to go through this because more or less you're quite familiar already. Just want to highlight that for this one and this one, you can have isomers. And to be more precise, I want to highlight that you can have positional isomers. Okay, that's where the OH group can actually attach to itself to different carbons. So for this one here, you can have the proper 1-ol. You can also have proper 2-ol. Okay, this one, you can also have others also. I should not go through the name. Okay, so they did mention here, other than straight chain, you can have the branching out. So you realize for this one here, the isomerism, the focus here is on the chain isomerism. But what I did here was to show you that you can have positional isomerism. Okay, you can also have this thing called the functional group isomerism. So let me give you an example of a functional group isomerism for this fella here. Okay, so let's use C3H8O. Okay, C3H8O. Okay, now I will show you a functional isomerism. That means the functional group is different. It's no longer alcohol. This is called ethyl, ether, where you have this carbon bonded here. So can you see this part here is not your regular O bonded to H bonded to carbon. This is a O linking the two carbon chains together. So this is called ether in general. Okay. Don't need to know what functional group this. Don't need to know the homologous series name. You just need to know that this is another way your alcohols can actually form isomers in terms of functional group isomerism. Okay. Any questions for this part? Thumbs up if okay. Thumbs up. Ding. 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 Okay, good. Okay, so every single time when they ask you for isomers, you can think in terms of chain isomers, where it's about branching. You can think in terms of positional isomers, where it's about the functional group being shifted to different position. Or you can think of functional group isomerism, where the functional group changes. It becomes a totally different homologous series. Okay, so take note of this tree. Most people will confuse thinking that functional group isomerism is positional isomerism. That's not true. Okay. Okay. Let's pause at this point. Any question? Thumbs up if okay. If you got any question, you can unmute yourself and ask me. Any questions? No question, thumbs up. Then I know I can move on. No thing. Okay, thumbs up, thumbs up. More thumbs up. Yes. Very good. Okay, let's go on. Okay, now, so physical properties. Actually, you realize it's very similar to alkanes and alkenes. Okay, but I just want to highlight one point. These alcohols, okay, they're actually liquids at room temperature and pressure in general, the shorter chain ones. Okay, they actually have higher melting and boiling points compared to the hydrocarbons with the same number of carbon atoms. So that means if I compare C3H8, this is ethane. I compare C3H6, this is ethene. Not ethene. This is propane. This is propene. Then I compare C3H7OH. This is propanol. Okay, there is a very big difference in terms of the, there's quite a big difference in terms of the melting and boiling point, okay, for alcohols. okay, in terms of comparing just the 3-carbon alkane and alkene versus a 3-carbon alcohol. So the alcohols tend to have a higher melting boiling point. Okay. Don't need to exactly know why. You will cover this in tertiary education. You won't cover it now. Okay. Okay, next. Okay, so in terms of physical properties, not just about melting boiling points, it's also about the trend as well. The trend that you see in physical properties is, okay, we're not going to look at viscosity here. We're going to look at solubility. We're going to look at melting and boiling points. So the physical properties here is not your viscosity and melting boiling point, but it is about solubility and melting point, boiling point. Okay? So it's no longer viscosity, yeah? Now, so in this case here, as the carbon chain increases in length, the solubility decreases down the homologous series. Okay, so you realize that it gets less and less soluble as the molecule gets bigger. Okay, so as molecule gets bigger, okay, as alcohol molecule gets bigger, okay, the solubility decreases. Okay, so that's in terms of solubility. In terms of melting boiling point, it increases down the homologous series. The reason you realize this is the same as the alkane, same explanation as your hydrocarbons. So I'm not going to go in details into this. So as you revise your hydrocarbons in terms of the melting boiling point, okay, you can just take note the explanation is exactly the same. Okay. So these are just some of the examples highlighted here. You realize solubility as you go down, right? As you go down the homologous series. You realize solubility decreases. Solubility decreases. Okay, as you go down the homologous series, the boiling point increases. Okay? So this table is just to highlight the 2 points that they mentioned here. Okay. Now, so physical properties for alcohols, we are done. Just mainly solubility and melting boiling point. We're now going to go on to the chemical properties, which is the reaction. Okay, we're going to look at the reaction. Now, for reaction, they have the one common example across all hydrocarbons, which is combustion. Okay, combustion. So alcohols also undergo complete combustion to produce carbon dioxide and water. Okay, this is an example here that they have done. Now, I want everyone to try this now. So I'm going to give an example, which is C2H5OH. I want to let it burn in oxygen to get carbon dioxide and water. Okay, I want to balance the chemical equation. So let's do about balancing. Austin, you just joined. Okay, help me. What's the order in terms of the elements that I should balance? What element should I start first when balancing this combustion?
You start at the right hand side.
No, I want
Like-
the element.
Oh, what do you mean, like oxygen?
So you start with oxygen, is it?
Yeah,
Then
because
after
it's just a lone O2 on the left hand side.
Then after that,
HO2, having H2O.
then after that,
Isn't that it?
no, then your carbon, eh?
It's a good question.
Good question, huh? Okay, next, Kiran, help me.
Oh,
Kiran,
you sucks at this game.
Kiran, come help me. Kiran. What? Can you unmute yourself so that you can help me? What is the order in terms of combustion for me to balance? What's the order of elements that I should balance for me to balance combustion equations? Okay, CHO, correct. So you start with the carbon, then have to go to hydrogen, then oxygen. Okay? So first thing I'll balance will be my carbon. So I got 2 carbon over here. So in this case here, I must have 2 CO2. Next one, hydrogen. Take note, the hydrogen is split across the H5 and the H over here. So total there's 6 hydrogen. So I should put 3 over here. In terms of oxygen, okay, take note, I got 3 oxygen over here. I got 4 oxygen over here. Total, I got 7 oxygen. Now, please take note, you got 1 oxygen here already. So I must minus 1 oxygen first. So I need my balance 6 oxygen to be from O2. Then this will be a 3. Okay, so the complexity in balancing combustion equation with alcohols is that always take note there's this 1 O over here. Okay, the order is still the same, carbon, hydrogen, oxygen. It's just that when you balance the oxygen there, okay, you need when you're balancing oxygen, you must take note of the O from the hydroxyl group in your alcohol. Okay, so this is just for you all to take note when you are doing your combustion balancing equation for alcohols. Okay, next one. Okay, next reaction that alcohols undergo, not just combustion, they undergo oxidation. So alcohols, okay, will actually undergo oxidation to form carboxylic acid. Okay, so you can see here, I know alkenes can become alcohols by hydration. Now I know I can get my alcohols to become carboxylic acid using oxidation. So how exactly to do this oxidation? Okay, so you will typically heat it with an oxidizing agent. The one that we have in the lab that you will frequently see in your test and exam papers is your acidified potassium manganate 7. Okay, so this is KMnO4. So do take note, for this oxidation to occur, the alcohols with the hydroxyl group must be bonded to the terminal carbon, which means that it must be on the 1 carbon position. Or it must be on the first carbon position. So what do I mean by that? For example, if I have 3 carbons, the OH cannot be here. Cannot. The OH must either be here or over here. So it must be at the sites, must be at the last, or first or last carbon. That's what they mean by the terminal carbon. Okay, only with it being at the terminal carbon, then you can get carboxylic acid upon oxidation. Okay, so take note, it must be at the ends. Okay, it cannot be in the middle, otherwise it wouldn't work. Okay, your carbon must be the end carbon. So this is an oxidizing, this is the oxidation of ethanol as follows. So look at the general equation, look at the word equation here, ethanol plus oxygen from oxidizing agent. This one normally is KMnO4 minus, KMnO4, sorry. Okay, you heat it up, you get ethanoic acid and water. You see here, I am not going to write KMnO4 because actually the reaction is a lot more complex. Hence, in order for me to write oxygen from oxidizing agent, I won't write KMnO4, I'll just write it like that. So this represents oxygen from oxidizing agent. And how many do I need? I need 2. So take note of this chemical equation over here. When you use oxidation on the alcohol to get carboxylic acid, it gets you will represent it with this weird square bracket oxygen. Okay, this represents oxygen from the oxidizing agent. Okay. Any questions for this particular part here first on what I mentioned just now? Thumbs up if okay.
Wait, Mr. Eugene, why can't I
Yes.
just write like O2, like as the, yeah.
Because O2 is oxygen gas. But you don't have oxygen gas from the KMnO form. What you have is actually the in KMnO4 is actually this one here that gives you the oxygen. But you can't write O4 because O4 is not a compound on its own. Make sense?
Yeah. But like, then the brackets is like must put lah.
Yeah, must put. So that's why the bracket is important. Is to say that it is not an oxygen atom. It is the O from a compound. Okay, the bracket tells you that it's the O from a compound. Can? Okay, thumbs up if okay. Okay.
For Mr. Eugene, do we need
Yes.
to know like the exact value of the temperature when they say heat?
Don't need. For this one, don't need.
Okay.
Just heat only. This one no specific temperature.
Wait, so like in the exam, if they ask you this, you just say just heat the solution.
Yeah, because this one you can do in the lab. You literally just let it boil lah. Then you can.
Oh, okay.
Okay. Now, I want to go into the reaction now. I want you to take a look. I want you to focus here. So what actually happens is, can you see this is the terminal carbon? Okay. Look at what happens to the terminal carbon. So you focus on this part here. What you realize is that it will lose 2 of the H. It will lose 2 of the H. And then it will form a C double bond O. Can see? The OH remains there because carboxylic acid still contains the OH hydroxyl group. Well, I won't say, actually the reaction is a few steps on, but you don't need to know this more when you go for tertiary education. So for now, just take it as the 2H is removed and you put a double bond O to that particular carbon. Okay, Ken? Any questions? Joachim, any questions?
No.
No? Okay, so you help me with this one now. So I'm going to use propanol now. Propanol. So let's draw propanol. Okay, let's draw propanol. Hey, propanol was a formula. Joachim, help me first.
C3H 267 OH.
Okay, C3H7OH. So C3H7OH. Okay. So C3H7OH. I'm going to let it react with oxygen from the oxidizing agent. I'm going to heat it up. Okay, what am I going to get here? What happens? This one, Matthew, answer.
You get, as in like the structure formula for the product.
Yeah, what's the structural formula?
You got 3 C's.
3 C's, okay, good.
With your last C, the H terminates to be a double bond O.
Like that, is it?
Yeah.
Okay, then the rest?
Just hydrogens.
So you realize the reaction only occurs at the functional group, correct? So I want to go back to the idea that when you do organic chemistry, a lot of the reaction actually occurs at the functional group itself. Okay, so just take note of it. At the end of the day, I will also get water, H2O. Can? Okay, so this is the reaction, how it is. Not very complex itself. Just get to know what happens at the functional group and you'll be safe already. Okay? Okay. So actually the breath analyzer, when the people drink and drive, right? The breath analyzer, they actually have ethanol inside the person's breath because drink too much, right? Then the breath analyzer actually causes the ethanol there will be some sort of oxidation happening, which causes the sensor to change the reading. Okay? So this one is just extra info, just for you to take note of. Extra, nothing too exciting. Okay, now, esterification is the formation of esters. You can see here, they talk about it in alcohols because alcohols plus carboxylic acid give you esters. Okay, but they are not going to cover here. They only cover at the later part, which is under your carboxylic acid. Okay, so that's for this part over here. Let's carry on. Now, next one, we're going to look at how is ethanol formed. How can I get ethanol? Okay, how can I get ethanol? So this is where you can actually do this at home. Okay, I say again, you can do this at home. You can make your own alcohol, which is fun. Okay, so I'm going to show, so see, one way to get alcohol, which you have already learned, is the addition of steam to ethene. So this one, I'm not going to go through because we have already gone through this one already. Okay, so just must recap, this is how you can get alcohol. This one you cannot do at home because you cannot have 60 atm. You can't get phosphoric acid easily unless you do some things to your coke. And the last one is you can't get it at 300 degrees Celsius that easily as well. Okay, so you can't do this at home to get alcohol. Plus ethene is also not readily available. But what you can do at home to get alcohol is actually fermentation of glucose. Do you have glucose at home? Very easy to buy one. Your sugar, a lot of them actually contains your glucose. Okay, so you can do this thing called fermentation of your glucose, and you can actually get alcohols with it. So what happens is that alcohol fermentation is the process in which yeast, your syllabus you're going to learn here is yeast, acts on the glucose where there's no oxygen. Must make sure no oxygen. They will produce ethanol and carbon dioxide. Okay, so normally your beer production and stuff like that, actually they make use of this process to get your alcohols. Okay, nothing too exciting about this. Actually, you can make it quite easily at home. Now, so the fermentation of glucose is actually represented by this. So glucose, arrow, the condition is to have yeast over there, and actually absence of oxygen. Okay, because it's anaerobic respiration, absence of oxygen. And then what you're going to get is ethanol plus carbon dioxide. Ethanol, carbon dioxide. Okay? So this is a slow reaction, but at least this is sustainable because your starting materials are actually obtained from plants. Right? Because you can actually use fruit juice to make this reaction as well. It may not be like processed sugar. You can actually use your fruit juice. Just have to put your yeast in for it to work. So you can go online. You can actually buy the yeast. You look out for this thing called the wine yeast on your Shopee or your Lazada or any online place. Look out for wine yeast. You just put the wine yeast together, kept it in your with your fruit juice. Okay, it will ferment, and after that you can actually get your alcohol. Okay, so this is actually how the simple setup can look. Okay, this is actually how the simple setup can look. The more, if you go online and check out YouTube, sometimes they'll have this thing called I can't remember what's the exact thing called. So instead of having a cotton wool there, they'll actually have, let's say I do like that. So this is the fun part, right? So they actually have a stopper here. Okay, they have this thing that goes in a circle. Okay, it goes in a circle like that. Okay, I don't know how to draw it, but in general, there will be some sort of a water at the bottom here. So it allows air to escape, but doesn't allow air to come in. So I know this is called an air trap. So it prevents air from entering the system, but allows air to escape. Why? Because actually when you do fermentation, carbon dioxide gas is produced. If you don't let the gas escape and you just let it, you just put a stopper, your whole container will explode. Okay, so it's important to make sure that you have the air trap where you allow the air to come out, but you don't allow the oxygen to go in. Can?
Wait, Mr. Eugene, how long does this take?
1-2 days.
Like to get wine or like beer?
Okay, so 1-2 days you get some alcohol already, but then you realize what they say here is approximately 1 week. Okay?
So if in 1 week it's already, you can already drink it.
You must filter the thing and stuff like that. Okay, but just take note, I don't suggest you do it at home just because I teach you here. Go and check out some YouTube videos. They got some things for you to take note of in producing this. Can?
Okay.
Okay, so but this will be fun. There are fun experiments at home, okay? Don't say I teach you how to make this, okay? Although it's recorded on YouTube, but yeah.
Mr.
Okay.
Eugene,
Yes.
can we do this when we get back to school?
Don't need, you can do it over the holidays. Just take Shopee. Just go Shopee and then buy
But
the wine yeast and then you
Can you
buy
mass
fruit.
produce
Can
it?
we leave it in the classroom to ferment?
Can
No.
we share it among ourselves after we're done?
You are not allowed to bring alcohol to the school, please. Don't anyhow.
Why
Why can't I just-
we're
Why
not
can't you
really
drink hand
doing it.
sanitizer?
I think I need to mute all of you already.
Why can't you
Okay.
drink hand sanitizer? Doesn't hand sanitizer alcohol?
You
But-
drink lah.
But then the hand sanitizer contains other compounds which you cannot drink, So there's other things as well that's toxic to your body, so you can't drink hand sanitizer.
So what if I
No,
selectively
Austin,
drink the
no, it's
alcohol?
fine, it's fine. You can just drink it. Don't worry. There's nothing inside that will harm you. Just drink.
Don't stop it.
Just drink,
Okay,
no problem.
Stop. Let's continue. Okay, let's
Okay,
continue this.
Zhang Yishan throwing right now.
Okay, let's go. Okay, now, so take note that ethanol and carbon dioxide gas are actually the products of the fermentation reaction. Okay. If you want to get purer ethanol. Purer at home, purer. Why is that purer? Because you can't get 100%. There's always some impurity there. There's always some water involved. But in general, you can actually make your ethanol purer by letting undergo fractional distillation. Okay? Any questions so far? So far, okay? This part, can? Okay. I just need you all to know that when you do this reaction, now the longer you leave your yeast there, it doesn't cause the alcohol in content to increase. Okay. In general, after that 1 week, depending on the quality of a yeast, some of the yeast can go about 15 or even higher, but you can reach about 15% ethanol. Okay, your beer normally is about 7% to 8%. Some can reach 10%, but 15% is almost at a wine level already. Okay, almost at a wine level, like lower quality wine level kind of percentage. So 15% is quite a lot. Why it cannot go beyond this is because the yeast will die because of the ethanol. Okay, once you reach about 15%, your yeast will start to die already. That's why they max cap about 15%. The better yeast can go higher, but it will not go beyond a certain amount because once there's too much alcohol inside there, they will actually die from it as well. Okay, but you can actually reach about 15% of ethanol based on this reaction. Okay, so you want to make it higher percentage, you can go and do your fractional distillation, you can boil the water off a bit. Okay, but just take note, if you leave your ethanol out in the open for too long, okay, oxidation will occur. So I want to go back to this part here. Okay, oxidation. If you leave your ethanol for too long in the air, right, it will actually cause your alcohol to react. I realize down here don't have any more. Last time in the old syllabus there is. So your ethanol can actually react with oxygen in the air plus the presence of some bacteria. Okay, but in general, bacteria is around. So, but we will normally override the bacteria, just put oxygen in the air. So ethanol can actually turn sour. Your wine can actually turn sour if, okay, you leave it out in open for too long, because the ethanol will slowly get oxidized to become carboxylic acid. So if you got ethanol inside your wine, you got beer as well, there's ethanol. You let it undergo oxidation, it actually becomes your vinegar, which is ethanoic acid. So just take note of it. Okay? So this puts it up quite nicely in terms of wrapping it up in terms of production of glucose ready, production of ethanol. Okay? Any questions up to this point? So you learn about combustion, you learn about oxidation of alcohol to carboxylic acid, you learn about how to produce ethanol two ways. One is addition of steam. The other one is addition of steam to alkene. The other one will be fermentation of glucose. Okay, any questions at this particular point? Thumbs up if okay. Okay, let's go. Now we're down to the last two parts, which is carboxylic acid and esters. Okay, so what are carboxylic acids? They're acids. I think most of you already know what they are because we have gone through it. They contain the C. Let's go through this. Okay, so they're organic compounds with the carboxyl functional group. So they need to have this C double bond O OH group. This is known as your carboxyl group. Okay, so nothing too exciting about this. I just need to take note of the general formula. Now, the general formula is CnH2n plus 1 COOH. But I want you to put a star here. Can you see this n equals to 0? So far, we have always started with n equals to 1. But in this general formula, my n starts with 0. Can anyone tell me why? Anyone to give a try? Austin, Kieran, Joachim, Matthew, who wants to give a try?
Wait, what n? Like the n?
Why the general formula, the n cannot start? You see, like when we do our general formula for like alkanes, the n starts at 1 onwards, right?
Yeah.
But then for this one here, you realize you say n starts from 0. Why? Why n cannot be 1?
Because there's a plus 1. There's a plus 1, so minimum of it can be 1.
No, it can be.
Right.
No, my n can. But down here also, I got CnH2n also. The N can also start from 1. I got CnH2n plus 1 OH. My N also starts from 1. But this one, how come N starts from 0?
Oh, it's because you just need a COOH for it to be a carboxylic acid.
Okay. The idea here is because your first member is methanoic acid. Methanoic acid contains how many carbon? Austin, come help me. Meth, how many carbon? 1 carbon. Okay. I'm going to show you if N starts from 0, I'll get C0H. C0H. C0HCOOH. So I get a Z. So if N equals 0, I get HCOH. If N equals to 1, I'll get CH3COOH. Now, methanoic acid contains 1 carbon. You realize that if N equals to 0, I got 1 carbon over here. But if N starts from 1, you will not have 1 carbon. You have 2 carbons. So if N starts at 1, this is actually ethanoic acid. You will not get your methanoic acid. Make sense? Thumbs up if okay. Yeah. Okay. So just be careful of the general formula for carboxylic acid. The N doesn't start from 1. The N starts from 0 because of the carbon at the functional group. Okay, so that's the first part here. Next, there's this 4. I will not bore you with this. I think by now you are fine with it already. So I will not bore you with this thing here. Just remember carboxylic acid. Functional group, COH. It's always at the end. Always. Okay, always at the end. Okay, and always remember there is a meth F prop but 1 carbon, 2 carbon, 3 carbon, 4 carbon. Okay? So formula, I think by now you are familiar, so that's why I don't want to go take too much time on this. Physical properties. Okay, the focus here is actually just purely on the boiling points. Okay, what you know is that the gradual trend in boiling point is because as you go down the homologous series, the boiling point increases. Reason, similar to alkane and alkenes, because the molecular size increase, the intermolecular force of attraction increases as well. Okay? So the physical properties for carboxylic acid, the focus is just on the boiling point and melting point. Nothing too exciting here. Any questions at this point for physical properties? Thumbs up if okay. Joking okay? Kieran, Austin? Okay, good. Okay, next. Now, physical properties explanation, realize it's on chemical bonding, so quite a fair bit of explanation there. The next one is on the reactions. So chemical properties of carboxylic acid, so we're looking at the reactions. Because they're acids, they will exhibit acid behavior. What do I mean by acid behavior? It means that they will produce H plus ions. So you can see your carboxylic acid, reversible arrow to give you your carboxylate ion with hydrogen ion, reversible because it's a weak acid, which means partial ionization. Okay, to form H plus ions in water. Okay, or when dissolved in water. Okay, now, so let's try this out. Writing the equations for carboxylic acid. So, Joaquin will help me. CH3COOH. I let it dissolve in water. I have double arrow. What is the 2 ions that we produced?
Hydrogen ion,
Hydrogen ions, that's the first one, plus.
carboxylate ion
So what's the formula?
of carboxylate ion.
Yeah, I got CH3COH, right? So I give you the acid here. So when I dissolve it in water, I'll get H plus, and then I'll also get What's the
COH.
COH?
COH.
COOH.
I don't know.
Okay, so you see, the H plus comes from the H over here. What do you think is remaining?
CH3COO.
Yep, CH3COO, and this is negative ion. Can? Okay. Any questions for this one? Thumbs up if okay. I purposely ask this because I do know some of you don't understand how the whole dissociation works. Because once you got R there, you know what the crap R is. So in this case, this CH3 over here represents the R. It can tell you that it can be any single donkey molecule. I don't care. Okay. So I'm going to give another example for you to try. So Matthew, you help me now. Okay. So I'm going to give you this weird molecule. Wait. So I'm going to write the thing here. When this dissolves in water, this is still an acid because you can see there's a COH here. What is going to be my product?
H plus ion.
H plus ion and?
That the like pentagon thing.
Okay. Hexagon thing, yes. Then?
Dash CH2
CH2, then?
dash COO minus.
Okay. So I hope you can see how that this dissociation works. It's really the H plus from the COH that comes out. The remaining part of the molecule stays the same with a minus on the O there. Okay. So take note of this acid dissociation. Now, for the rest of this, okay, you realize that they say reaction with metals, reaction with carbonate, reaction with bases. You realize that this three is your acid reaction. So acid can react with my metal to give me salt plus hydrogen, salt plus H2. It can react with my carbonate to give me my salt plus water plus CO2. It can react with my base to give me salt plus water. Okay? I will go through this a little bit because the naming convention needs to be there. So let's take a look at this. Now, acid plus reactive metal, I get my carboxylate salt. So if I got carboxylic acid, I got carboxylate salt plus hydrogen. Now, the naming of the salt, I need you to be able to do it. So let's take a look carefully. Magnesium plus ethanoic acid. If I use ethanoic acid, my salt will be called magnesium ethanoate. Okay, magnesium ethanoate. Then I'll also get my hydrogen gas produced. If I use propanoic acid, what do you think is the name of the salt produced? Something what? Austin, help me. What do you think is the name of the salt that's produced?
What?
If I use propanoic acid plus metal, then I'm gonna get a salt, right? What do you think I'll get?
Propanoic acid with metal.
So if I use propanoic acid react for metal, okay, let's say magnesium, I'm gonna get magnesium what as the name of the salt? What's the ending part of the salt name? If I use propanoic acid, make a guess.
Proper weight.
Okay, so it's correct. It's proper, no. So you realize it goes all the way until the OR. But instead of IC, you do a ATE. Okay, propanoate. Is it okay? Thumbs up if okay. Thumbs up. Think react.
Wait, Mr. Eugene, is
Yes.
it propanoate or is it propanate?
Propanoate.
OATE, right?
Yeah, OAT.
Okay.
Okay. So what if I use metanoic acid? Just now was Austin. Kiran, can you type it out? What would I get if I use metanoic acid? What would be the name of the salt? Metanoate, good. Okay, so it'll be something metanoate. So I want to do all the 4 examples. So I got ethanoate, which is for 2 carbon. I got propanoate, become propanoate, which is 3 carbon. Metanoate is 1 carbon. The last one I have is butanoic acid. So I spelled too many. Wait, butanoic acid. So if I were to let it become a salt after reacting metal or carbonate or whatever, I'm going to get a butanoate. Okay, so this is for the 4 carbon. Okay, this naming is important because when you do your ester, all these names will actually be useful. Okay, so they react with reactive metal, they react with carbonates, they react with bases. Okay, so these are like your usual acid reactions. Now, please go and study the equations a little bit. If you've got any questions regarding why is it like that, in terms of why the 2 here, why the bracket, let me know. Okay, but in general, this is actually just your simple balancing the charges and stuff like this. Okay, this is more under chemical formulas. Okay, this will be the last reaction for this part already. Okay, so they react with your metal, carbonate, and bases. They also react with alcohols. When they react with alcohols, they actually form esters. So esters actually is another homologous series. Okay, esters is another family. The functional group for esters, so esters are another homologous series, they're organic compounds. They actually contain this functional group, which is C double bond O. Like that. So you will see this linkage, they call it a linkage, this ester linkage, where you see this functional group over here. You realize, hey, sure, this one look very familiar. Looks like what? Matthew, can you tell me if this looks similar to what?
Like the functional group,
For what? Which particular homologous series?
carboxylic acid,
Yep. But the thing that's missing is
your H.
H. Because this fella here is bonded to another carbon. This fella here is bonded to another carbon. So that's why there's no H there. It's just this C double bond O, single bond O. And then both sides are bonded to a big chain carbons, and bonded to carbons on the 2 ends. Can? Thumbs up if okay. Okay. So let's carry on. You need to learn the reactions. Okay, so 20.3 is later on. So later on, you will see this a bit more in detail. Okay, next one, formation of ethanoic acid. This is the one that I mentioned. So how can I get my acids? Right? I told you ethanol can undergo oxidation. This one, finally, you'll see here. So ethanol plus oxygen from the air with bacteria present, you get ethanoic acid and water. Okay, this was what we went through just now as well. So this one is the same as the one in alcohol side. How to get ethanol react potassium manganate 7 to give you your ethanoic acid. This one is just in general from the air, oxygen from air. Okay, then you can get ethanoic as well. So these are the how to get your acid, how to get acid. And you realize the common examples they always give is ethanol, ethanoic acid, ethanol. So you realize the common question that they like to give, or common example they like to give, is actually your 2 carbon alcohols forming your 2 carbon carboxylic acids. Okay, but they can do single carbon, they can do triple or 4 carbons as well. So it's just that the examples here are mainly on ethanol. Okay. So this reaction of alcohol plus oxygen to give you your ethanoic acid, I want you to realize that there's a difference here. So with air, you realize it's just O2. If I use oxidizing agent, you realize it's a 2 bracket O. Okay, there is a difference like what Matthew asked just now. O2 is oxygen, like literally oxygen molecule. 2 with the square bracket O is trying to say oxygen from the oxidizing agent. Okay? At this point, pause. Any question? Thumbs up if okay. Oh, only Matthew thumbs up. Joakim, Kieran, Austin. Aha, purposely I don't have pressure. Waiting for me to ask you. Okay. Now, we are gonna finally go on to what are esters ready. Okay, what are esters here? Actually no, I think time is quite limited. I think I won't go through esters. I think this is enough for today already. We will go through esters more specifically in the next round. Okay, Ken? So that's all for today. I will stop the recording now.